I guess we are live. Oh, I forgot my booster. Give me a second. My booster is in the fridge. But okay, let's wait a second. Let's wait a second. Ah, the sun is so bright. Ah, you know the meme where the dude closes like it's New Year's Eve and there's fireworks outside and he closes the curtains. Yeah, that's me. All right. So, what did I do since yesterday? Nothing is the answer. I tried to clean up and sort my parts. Still, um, yeah, I have one more bench that we can use to debug stuff, but I will put on the I'm early. I'm streaming early. By the way, I found the missing bolt here, but it's not in my jacket here. This extra bolt here. It was still on the floor in front of my shed. Hey TMK, hey Dishipu. I'm so thirsty now that I know that there is a booster waiting for me. I just went to Netto and got a booster. You saw that? Oh no, I missed that message. Sorry. I didn't acknowledge and missed that. All right. So apparently I'm using, wait, this is, I should be careful with my parts. This is from the power, because I have now, I decided to have like separate 3 boxes for power supply, ATX stuff, all the parts for the main build, because otherwise it's really difficult to find anything. So this needs to go. Ouch, gross. What is this? Quartz. Hey Sonic. This goes in the FPGA box. And this goes there. This goes there. And this needs to go there. All right. So on my plate today is debugging the power supply and testing this device here. So I would start with testing the device, as this is more important, and then we will stream for 2 hours, so not a long stream today. Okay. Sun is too bright. Here we go. What we need now is power up. This is the power, 3.3 volts, supplying that, and we need USB. This is I had a description. What was the description for the USB plugs? Does it say anything on the? Oh no. It doesn't say on that, but I think there was on the on the Amazon listing where I got this. Where did I buy it? They got it from Amazon or eBay. I think it might be eBay. Let me check shortly. So we know how to hook up the device. Also, I'm not satisfied with the soldering here. If you look closer, yeah, this center one doesn't look that nice. Hey Dutch. Okay, let me check the. I think I got it eBay, or did I get it for? Yeah, it's looks disgusting. Okay. Ah, here it is. Whoop. We have. Yeah, that's USB 2. Ground is black. Let's turn around this whole thing. Let's remove the frame. Oh, wait, we can use it like that. Schnapp not schnalle. Oh, that doesn't. Oh, it doesn't fit this way around because of the connector. Yeah. Oh well, we have to work with that what we got here. I'm wondering if I should crimp JST that I just put on top of that. I also need to figure out which connection is what. I didn't do any silk screen here. Okay, close to, wait. This one is VBus, we don't need that. Then we have CC1. Usually we wouldn't even need CC1. We can just use 5 pins because VBus is not necessary. So, and I actually don't have 2mm JSTs with 6 connectors, like the sockets. I checked. Schnaps, what? Where's the 2mm? This is JSTPH. Where did I put it? Give me the connector. Apparently, I'm not finished with cleanup yet. Oh shit! I just lost a few of the good caps. A few of the good big caps. Oh, your VPN? Yeah, they have to analyze all your traffic. That takes a while. They are sending it through some AI to analyze it. Free Firefox VPN. How does that work? There needs to be somewhere a server, doesn't it? Oh, that's your limited traffic. Sounds interesting. Are there any hurdles? Why you need to make it work? Like, what is the difficulty? Hello, Samosa. We're working on the ultra cluster. Oh, in waves. Okay. About config. So you can basically enable it manually. There it is. I put it in the parts box. Okay, here we go. 2 millimeters. We have. Hey Casper, that's alright. Okay, I'm wondering if we can just get it. If we can just get it, this if I put it on there, yeah, that will be just the right size. So let me get out the pins in Soapmayo form. We just press them out and put the JST on. It's a bloody heck. Oh, they are. The pins are tight in there. Can't get them pressed out. And should I? Oh no. Should have soldered the 5-pin right away. Not no. This header is 2 millimeters and the JST, they are different sizes, and this is a 2 millimeter JST. There are PH, T, whatever. There are like so many JST specs. And I'm using 2 millimeters here, and both. That's why I think I have even like all the sizes in JST 2.54, but or 2.5, because but not in 2 millimeters. That's why I'm pulling out the pins, and we'll just put it on this header. All right. So we don't need a V-bus. V-bus is here. So we will just do it like that. Oh no. The V-bus. Here we go. Oh, that's too short. I need to pull off the plastic as well. This is how I break this board. Okay, I hope it comes off. Nope. To be careful. Let me check where. I mean, everything is in on the second layer except for small sections. We'll just pry it off. Otherwise, if I try to cut it, it will stabbing myself. this side is coming up, but this isn't yet. Now it is. Here we go. Boop. Blah blah. We don't need anything. We just do it live. Here we go. Oh, this one pin doesn't, the V-bus pin on this side doesn't like it, but oh well. Maybe I should just desolder it. No, I leave it there. It's my special treat here. Wait, it's not connected anyways. I can just clip it off. V-bus is not connected on the PCB. Oh, this is now so well in, I can't pull it off anymore. Yeah, I can just... ship it. I will just desolder it. Ah. Maybe off camera. Oh, come on. Why is this so short? Okay, maybe my thing is too long here. Okay. I pulled it out a little bit. Need either flux or solder there. Where is the solder? Give me solder. Alright, I hope I didn't damage anything. But V-bus is out. I don't know why I even routed it. There, it doesn't need to go there. So, sorry. We have now a JSD. I have 4 more of this, so no worries about that. Now we can crimp the connectors. I don't think we need V-bus, so I will leave that. Where's the USB? Where's the USB plug? Lost it already. Gone. Eh? Where's the plug? It's gone. It's not on the floor. It's not here. Thankfully, I bought multiples of those. All right. Hey Natsu. Okay, so we have the JST, and I don't know if I'm doing this right. My tool is a little bit cranky already. Oh, come on. Okay, let's do 1.6 instead. Why does it rotate? Okay. Let's start with 1.9. And then go tighter. Oh, that looks good. Okay, that's the ground. Then we have VD minus S. Wait. What is this color? Is this blue? Yeah. Blurple? Yeah. That's my color vision. Fuck. My fat fingers. Fat fingers are not suitable for this job. Fuck. Fell down. Still use it though. Yeah, just take the next best. Indigo. There is a trick for programming the ESP, the WCH over USB. We need to pull down or pull up. I hope it's pull down one side, but I don't know which one. Can you quickly check that? Like ESP, no, WCH USB ISP. There's, I guess AI knows it already. Okay, that's white. Uh-oh. That one is damaged. Okay. I hate crimping. Probably because I don't have the proper tools to do that. Must be a better way. Alright, that's one is missing. Blurple is missing. Hey Johnny, how was your nap? Or didn't it happen? You can take your nap right now. What? Tech what? What are you referring to? Okay, this one is not good. My precision is flaky at best. Oh. Oh, now I got it. Okay. Yeah, this is you. I used so much force, didn't help. That's a funny joke. Come on. Is it good now? Oh, dudes. And that's the references here. Alright. I guess this should be good. Now, let's check the connector. We need, so it's this way around. We have G and D is the last, so this is G and D. G and D. Then we have now we need CC1. What kind of color is that? Is this greenish? Yeah. Okay, then CC. No, wait, we need CC2. That's yellow. Next to ground. CC2. Then we need D minus, which is grayish. There is no gray. Wait, D minus is white. Yeah. Ah, come on. Okay, white. Then we have D plus is bluish or purple. And then we have CC whatever. That's it. And this needs to be protected or really cut off. Flush. Yeah, let's cut it off flush. So we don't short stuff. And let's connect it and see what happens. Okay, shall we just plug it into power and see how much current it draws? Okay, so let's use our power supply here. But we need to change the voltage from 12 to 3.3 volts. Ah! Okay, 100 milliamps isn't that violent. Okay. It's always minus. This is plus. I don't know why I took this big connector. We just need. Okay, maybe for later. All right, this is USB. This is power. Let's see what happens when I turn it on. It's not drawing much current though. I'm worried. 0.04 amps, like 2 milliamps, 3 milliamps for 3 MCUs. This doesn't sound like a lot. Okay, let me try to plug it in to my PC and see if there is like anything coming up. No magic smoke though, yeah. Hmm. Ah. Okay. How about I try to use use the linky to read that. It might be just idling. I have here my test suite. This is yeah. My SD card is full. That on top of it. Let me clone. Let me copy remove some data from the SD card. Sorry. Is there like a huge file? Eight gigs. What is this? Yeah, there's a ton of crap. Okay, let's see how much space do I have on C. Yeah. Is there a way to connect? Okay. I need a ground pin though. Or I need to get a pogo for that. Be careful. Don't have. You know what? I can solder on a header. I don't mind doing that here. Some wires. but do I want like to have that on each now? I really don't want to have it on every single one. Maybe we can read it somehow, but I really need a ground here. How do I get a ground? Where do I get a ground? This is ground here as well. Maybe we can do it like that. Yay, life. Yeah. I need a pogo. I just saw the pogo somewhere here today. Ah! That's not a pogo. Here. All right. I want a pointy one. These are pointy ones. Okay. Maybe I have a thinner one that will fit right in here. This one from, I think this one is from there. Oh wow, this manufacturing is a miracle. How can you make a springy pogo that's so thin? Alright, this is ground and the other ones are whatever. Now let me check my schematic. How to get there. This is the one. Is this the one? Yes. Ground is on this side, and then we have the two in the center. Okay, let me try to connect. What? Peeps. Look at that. You get the chip ID. This one is running. Nice. Okay. Easy. Okay, so we have that one running. Now we need to WCH ISP. I need to check. That's also a reference from A-Team. ISP USB setup or You need to pull something down on power up. Power supply. Which one is it? Where's the... Is D plus or is it D minus to pull down? I think it was D minus pull down, or the internet is so terrible. D peeps. Well, how do I do it? There was a way of programming it. Let me ask Gemini. Yeah, whatever. How do I program CH32V 3 over USB? I know there is a way of pulling down a D line to get it in DFU mode. Okay. Oh, it's D plus pull high. It says it's D plus pull high. Ay, okay. How do we get, okay, pull high, D plus pull high. We can try it using a resistor to get it in DFU mode. Or we get some thin wires connected soldered, so we don't need to do anything of that. It's so sad that I messed up. Yeah, we can do it. I will just get 3.3 volts here, and we can connect it, and it will show up as a USB device, but my thing is not copied yet, my stuff. The ISP Oh, the booster. I need to get a booster before it explodes in the freezer. By the way, my filament didn't arrive yet today, which is annoying because I really need it. I found in the kitchen, I found my tools, the wire stripper and the missing bolt. So that was a good. Oh, and the booster is so cold. It is condensing water. Ah. Ah, amazing. Ah. Ah. Yeah, you got your Sonic. You got your Red Bulls. Industrial leak? Yes, that's what it's supposed to taste like. Trying from what? From what to to which one? You didn't you try Monster recently? Oh, okay. The regular one or zero? Zero is hard to get. You can get it like in the cans. Regular, yeah. Otherwise, it's net negative, and you just like me shouldn't get negative calories. And this is certainly negative. Oh, I got another interesting factor on negative calories. No matter which sugar-free drink you drink, it's negative calories unless it's 37 degrees warm, because heating up water takes so much energy. You need like to ingest it, and I think that was a discussion of the Vsauce guy. About I think yeah that he was like discussing with that, I don't know, physics girl or whatever. No, it wasn't physics girl, but that the redhead, I forgot her name. They have like a, I don't know, podcast, or they do like skits on TikTok, and they were discussing about sugar-free drinks that they actually don't have like not yes, that's kilocalories, but you're allowed to have like 1 kilocalories per 100 milliliters or grams. That's also here it says Brennwert 10 divided by 2. It's not like 0, but still heating up the water to your body temperature takes so much energy, way more than you would ever get from like the kilocalorie that you have in such a drink. All right, I think my card copied, so vanilla Coke is not bad. The silver Diet Coke is, yeah. I'm like Coke Zero drinker, but the phosphor acid inside isn't good for the body. So I try to get off that. What do we have in here? I think the phosphorus is bad for like bones and okay, Zitronensäure. What? This one has Zitronensäure. So not Phosphorsäure. Phosphorsäure, I get like the impression that every time I drink cola I need to pee more than I drink. Maybe it's a trick for you to buy even more cola. Alright, we want to get D plus pulled up. So those bastards. Alright, peeps. Do we want to release some magic smoke? What is the tool that we are using for USB detection? That's USB log view. Oh, come on. Huh? The search doesn't find it or what? Come on. No log view, okay. Yeah, I know. Let me check my archive. I probably copied it there to be sure. Archive. Software. Yeah, Windows search sucks recently because of effing Cortana or whatever they try to force in my throat. Yeah. USB. I guess I had to download it again. Nearsoft. Yeah, that's the one. Wait. It's the third sip. Okay. Here we go. Log view. It's starting. Okay, let me plug it in and see if we get anything. We probably don't get anything. Yeah. We don't get anything there, but I can pull up. Now I need to find out which one is close. Which one is D plus is the blue one. Because it's supposed to go inside of a cylinder with some liquid cooling. Okay, I will. This is now not nice. I will use USB pull up and then we will power cycle it, okay? Here, power cycling. I don't know if it worked. I don't see it working. Oh, what did I do? Okay, there is a unknown USB device. But I need it's it's probably stuck in the okay, I get something, but it might be just yeah, it might be just an because I dig around there. Okay, let me start the ISP and then see if we can tools, language, English. Now we need to check risk V, 3, USB, and then didn't work. Okay, this is harder than I thought. Nope, not getting anything. All right, I will sort on the wires. It's way easier. Let's not dig around too much. It's wasted time and energy here. Will be way easier to have something like a linky that we can actually program and be good. All right. Let's find out where the pins are that we need. We need ground. Wait, this is the wrong one. Yeah. Actually close to USB I/O. Where's the clock going? Let's go to bottom layer. That's easy. Ground, I/O, and clock. That's on this corner. On the corner between those things here. Easy mode. Why is the transfer so... Something going on? Oh yeah, it might be because my hard drive is synchronizing the stuff that I copied. That wasn't good. We will try to do it under the microscope because that's quite tiny wires though. I found so many USB plugs. I don't need that many. Is it recording all the time? Oh no. Okay. Let's maybe... how do I not scratch the wheel of time? It cost me half a year of work. Disconnect everything. I might get weird power stuff going on, and then let's connect. Let's get this so that all right, that should be easy. Okay. Yeah, I think I need to get this one. Need to strip the wire though first. We got the ID from another IC, but not the main one. Like the USB thing we didn't get yet. We unfortunately have the programming pads covered, so I will just add new programming pins to the legs here. But this will... take a second. Maybe flux. Maybe I will just lay it flat, so we don't get problems later. Slight kink here, like that. Looks good. Okay. We can take any ground actually. We can also take this ground here. I don't need... Yeah, this will be good enough. But that's a different temperature soda though. That big blob. We have now some mix of sodas. I don't know if that is great. Yeah, but it will hold. Oh. I just set the clippers here. And also, I should use my gloves because yesterday I noticed I really need to use gloves more often, and I have some, so I should use them as well. I can't get off like the flux, it's so nasty, can't get it off my hands easily. So I have some vinyl gloves. Look at that. strip this wire. I'm prettying the tip of the wire so I can be sure that it will work. But it's off camera, sorry about that. And that's it. That was a quick one. Okay, now we need to get the other end attached to a header or something. Here. Let me get this all to one length. I'm wondering if I can get some solder on the wire while it's still enameled. Oh, actually, with this soldering iron it's not enough at 355. That might work. Oh, easy. Nice. All right. Okay, let me get the wires sorted. These are the data lines. Blue tweezers, here you are. Okay. Plastilina. Where is my plastilina? Give me the plastilina. Sing for me, Argentina. Here is plastilina. Stick. Oh, we have some 3D here. A really stereoscopic effect. watch through the microscope. Yeah, I spent like, what was it, 600 for the one with really that doesn't matter. Don't worry too much. It's only ground and data lines which can be pulled down. I had never issues with that. Alright. We can mark ground though, and data, and we have some. Where's my pen from yesterday? Here. This should be ground. Don't I have black? I had black yesterday here somewhere. Oh well. Let's give red. Now let's give blue, and we will figure out later. Let's add that. Now we need to be careful not to rip this off, my friends. Hey Flyken. So now let's try whatever I did. I don't know why we had like a doo-doo-doop, but something disconnected here. Alright, let's try to get the idea of this one. Yeah. Okay, I guess this is ground. I hope I connected it right. Very hair thin wires here. Let's power it up and see if it blows up in my face. Hope not. Oh, that was weird. In 12 volt, 3.3 volts. Okay. 5 milliamps. Now let's check. Let's check if we can get anything from this device. This thing. Nope. It's not. So let's switch to wires. Clock and data. And hope for the best. Nope. Huh? This is ground. This is... Weird. Power cycle? Nope. Switch again. Okay, I guess we have to take a closer look there. Let me check through the microscope if I did, or let's check the circuit first. That's basically a clone from this one. No, oh yeah, might be wrong pin though. Clock. Yeah, I switched them already. Okay. I/O. Clock. And that's the two. I hope I didn't connect this one, but I guess not. Let me check again. Microscope time. Okay. Yes, I connected it to USB. Oh, that's a fail. Look at that, it's connected to USB. Yeah. That's the USB pin. How did I mess that up? That was really not that difficult. Where are my tweezers? I need the tweezers now. Here. Okay, let's fix that. Yeah, gross. Here, that's done. It's blown out on the camera here. All right, that should be it. Ow! Oh, you checked, Happy? You checked and watched it back and then noticed. Okay. Okay, let's try again. I hear a sound, so it's not shorting anything. Now let's test here. ISP, let's see. Okay, let's flip the wires. Clock and let's flip the wires. Oh no. Oh wait, there is no power. Okay. because of the flux. The flux, I can't get it off. All right, I power it up, peeps. Power it up. Now failed. It's always the other way. No, flux is no good for skin. Here we go. All right. Whoo! Now we can program it with USB or whatever. Oh, we have only 30 minutes left. That's a short. What did I press here? We have like 30 minutes left. I guess we can stream tomorrow as well, but I wanted to go to Berlin, but I need to finish something. Like if I can make it, it will be really hard. GG, Bodo. Okay. We can program. I need a booster now. Can get the gloves off now. Not fluxing, not soldering anything anymore today. Let's code. What is this? Twitch can be annoying with some ads in my face. We want. This is level 2, but we can do level. We can copy that. Wait. How do we create new on River project? No. Ultra code cluster level 3, level 4. This is level 4. There is another level 3 coming, but this is the other one that we okay, V303 RTC RCT. Yeah, that's the one. Finish. Project name level 4. No, let's create a new window because we need to clone a few things. I want to use USB. Which pins are we using for the USB though? Let's check it out. We need to clone a few things from the repo. Wait, this is the one. 44, 45. That's the regular A whatever. So let's do 44. Program the pins. What does that mean? And there is no matrix if you there's like peripherals which are attached to specific pins. In that case it's USB, and we will there are basically preset. You can change, like flip them to different pins, like one peripheral. There's always an alternative, but there is not a specific matrix like on the ESPs. They have like GPIO matrices which are really cool. Okay, I need the USB stuff. I think we didn't have risk v. Let me get that. Platform IO is an abstraction on top of, like, yeah, it's more like Platform IO is rather a coding environment, or like a wrapper around different SDKs, and we are using directly the SDK for WCH. There might be Platform IO integration for this specific MCU. I'm not using it right now though, so it's the code will probably work as well with Platform IO. No worries. I don't mind explaining stuff because other people might be afraid to ask, and it's not clear. All right, so I'm looking for the the example so we can steal the code. Full speed, I think this is the full speed device. We have, that's the host, udisk, but we want device. Compatibility, CDC, and human interface, simulate CDC. I think I had an implementation for, I used CDC before with that. Okay. Yeah, they're using this okay, there's UART. USB device. I hope they don't use they might use this stupid library. Yeah, no, that's udisk clip. Okay. File system. Full speed. Wait. Full speed device. Simulate CDC. Simulate. Like CDC. Okay, let's open that up. Clone whatever we need to have CDC there. We just want to achieve that it replies something. So, oh yeah, that's okay. Let's put it side by side. Trolling, yeah. Troll me. We need to set the system frequency higher. Well, I can't move this. What is going on? Oh yeah, here. System frequency. I guess this will internal. We don't need like we were successful using the 120 megahertz internal. That's the first thing to change. Okay, then it's this debug, usart, printf, whatever, clock core update. We don't need that crap. This is something just made us scroll. This is documentation that can be done by AI later. Core clock update delay init. Hey Johnny, thank you for the resub. And the while, okay, infinite loop. Now let's check the code of this main. So we probably need this whole UART thing here. So I will add new folder, CDC. I call it CDC because it's slightly different. and I will put everything in one file, like one header. I don't know. Actually, there might be a link, but the environment the examples you need, like I downloaded them as a zip file from the server. They might be linked here. I know there is a link to the datasheets when you create one, or when you select, if you do it like new project or something. Wait. Project. Wait. New project. Where is it? Yeah. If you do new projects, there might be apply sample. Wait. CDC is serial like UART, but it's not. It doesn't use any speed limitations. That's basically full speed USB. It emulates that, but you can do whatever you like with that information. It's usually it's ignored. So that's basically like UART, but the most speed, the highest speed possible. Yes. So usually, if you connect to that, it will appear. You can connect to it from the browser of a web serial, and you can request whatever speed you like. In the end, it will be transferred way faster, whatever the limit is of your chain. Okay, I don't. Here it says apply sample. I don't know what that means. Oh, yeah. It opens a window. Oh, apply sample. Oh, you can get a sample of the MCU. There is no. Yeah, you can download. Yeah, that's possible with that in some cases here. You can program it over over serial, but yeah, with extra steps. Let's do a new file. We're on the clock. Yeah, it's very, very copied. Like the design is quite similar to of the peripherals and everything. At least at least for this the 32V versions. All right, now let's look what we got there. Let's copy that whole crap. Yeah. Okay. Okay, I guess we will just extern C. Nice. Let's copy that crap then. But we don't need extern in that case. Yeah, it might blow up in our face when we try to import that. Oh no, this function. Okay, let's copy it here. We don't need extern. Oh, there is attribute. Let's leave it. And clone that stuff. Ah. Pop. Allah. What's going on? What's the issue here? Where's this coming from? USB device, user USB device. FS device. Where is this coming from? Oh shit, there is like a bunch of those files again. You are okay, yeah, no, we just copy that whole folder. Okay, let's explore it then. I hope it doesn't require this stupid blob. Open containing folder. Okay, see. In that case, we could just as well wait conf. Where is it? Explore. Open containing folder. Okay, here we go. Why doesn't it find it here? Okay, let me just compile it and see what happens. No such file. Okay, device, USB device. Okay. USB device. Really, it replaced it. Not CDC. What is this doing? Trying to look for it at where is it? Yeah, that's yeah, that's not needed anymore. Okay, so buff first used in this function, not declared. Okay, where is it? Huh? That should be Attribute aligned. It's declared here. I don't know what this is. Why is it complaining though? What happened? Oh, is this some stupid okay. Some extra functionality. Huh? Oh no, that's endpoint, not txbuff. Okay. UART, let's check where this is missing. UART txbuff. I missed the whole. Oh, that's device. That's weird. Why is it? No, this is tx UART txbuff. It's accessing it here. Why it's not even defined there. Okay, let me find it here. Okay, extern. CDC, it's extern here, but it's not defined there. Extern CDCH. I removed it here, did I? No. I shouldn't have messed around with that. Oh! Oh, it didn't save my change here. CDC device. Okay. Device C. Let's just copy that. UART volatile. Where is it defined? We had that in UART C. This should be defined here in CDC. We copied that, didn't we? Define UART. Oh, it's missing. Wow, it's a bunch of text. Build fade, all right. Okay. Hey, you are. extern, and then we have definition here. Yeah, I shouldn't mess around with that stuff. If that doesn't work, I will just copy the other files as well. Build failed again. Okay. Buff length. Okay. I should just include that. I don't want to include it yet because that might like go in circles. We need to include it. There's no way around. But then, yeah, no, that doesn't work like that. All right, I give up. My messing around didn't work. Let's just copy the whole thing. Device and CDC. Let's just copy that. And copy the main. I hope that setup is simulate CDC. Hey Ozu, you're coming late. We are just about to finish here. Okay, that's UART. Timer, RCC, chip ID, USART. That's interesting. RCC configuration. Timer. Why do they initialize timer? And RCC configuration. Interesting. I would need to add the folders to the configuration. Where is this defined? That's device, USB device. Okay, let me compile it. Build failed. Okay, now build finished. All right, let's program it, huh? Here we go. Download finished. Do we get USB now? Moment of truth. Moment of truth. I plug it in. I plug it in. Get nothing. Oh wait, it is no. Unknown device. It doesn't do it right. No, it doesn't work. I know there is an issue. With the clock, I believe. Let me change the clock. I remember I did this once before. The clock is set to 96 external. Okay, let me change that. System. No, not simulate. Level 3. Yeah. 120 might not be the right frequency, so let's try that. Okay. Yes, I do. I do this for descriptor request failed. Download finished. Does it even go to external? Let me try doing it internally, because if it doesn't work with the crystal, I get nothing now. Okay. Let me try to upload this example. This shows up. No, it also fails. Okay, you know what? Let's try changing to internal as well. Or I got the things wrong. But I need to go right now. I'm so sorry. We would need to continue tomorrow or I finish it. That sounds, everything here sounds so familiar. We did this before. Unknown device. Yeah. Johnny, I'm trying to, but I need to get at least my communication with the device working, so and build it. So probably on Saturday, if I go on Saturday. Otherwise, I can't go. And it's in Germany, if you didn't know. Okay, peeps, I have to go right now. I'm so sorry. CDC flaky. I would need to think about it or check what's going on here. I will oscilloscope the crystal if we got the frequency that we need, and other than that, bye bye everyone. See you next time. Maybe tomorrow, hopefully. Bye bye.